Hello physicists and welcome. Hey, in this session you'll be looking at the simulation from PhET, Simulation and Net Force and Motion. Hey, make sure you read through all the directions here. This will give you just a quick video introduction to the topic. Hey, we're going to be looking at the change of motion from unbalanced forces. As you read through this, you'll click on this link to bring you to the simulation. Here we have the simulation. We're going to pick motion. Hey, let's see. We can apply force either to the right or to the left with our notes here. For this simulation, for the experiment, I guess I should call it simulation, we want to have our values, masses, and speed all set. Let's go ahead and like that. First time through, you'll be applying various forces to a 50 kilogram load. Notice that our speedometer is shown here both in the dial and digitally. I can apply a force. I'm going to pause this. You'll see why in just a moment. I can apply, say, hey, 150 newtons to this 50 kilogram box, and I'll go ahead and start this. 1001, 1002, 1003, 1004, 1005, 1006, 1007, 1008, 1009, 1010. Hey, so notice what happens when we get up to a speed of 40 meters per second. Our SimMan can only run at 40 meters per second. If he tries going faster than that, he falls down. All right, you'll be trying this at a couple of different forces. Hey, later on, you're going to apply a force in the opposite direction. You probably anticipate what's going to start happening if we apply a force in the opposite direction. Okay. Hey, so we'll slow it down, slow it down, slow it down. One of the things you're going to need to look at is you'll actually stop for a moment and see what happens after that. All right, this may have just given you a bit of an idea of what's going to end up happening here. Let's go pause this for just a moment. Let's go back over to our document. Hey, so you'll be running 3 tests with 50 newtons, 100, and 200 newtons, all applied to a 50 kilogram mass. Note here the time it takes until you fall, starting from starting at 0, how long till you fall with 50, 100, and 200 newtons applied to that 50 kilogram box. Okay. Calculate the acceleration. We know that acceleration can be our change in velocity over our change in time. The change in time is recorded in the column here. And then just as a matter of fun, go ahead and calculate this. Your net force, which is listed here, divided by the mass of the box. Figure out what your units are and go ahead and do that calculation. Please go ahead and answer the questions that follow down here, okay, and do the activities as listed there. Hey, so there's another part of this activity, and in this case, you'll notice that you're going to be applying the same force at all times, but you're going to change the mass that you're applying, but doing the same experiment. Let's go back to our simulation. Let's take a look at that. Okay. Hey, so I have one that's already going. Yeah, I'm going to go back to this one here. Hey, so in this case, I'm going to reset this. Okay. Put on all the values here. Hey, if I want to, let's see, increase it to 90, I'll put a total of 40 and 50. I now have 90 kilograms of mass here. I'll end up putting another 80 up here. Hey, now I have 170. All right, and then I want to apply, in this case, I believe it was 100 newtons. Go ahead and do the same procedure you did before. Okay, how long does it take for SimMan to get to 40 meters per second? We know at 40 meters per second is when SimMan falls down. Come on. I'll pause there for a moment. All right. Hey, so let's go back to this. We have a couple more questions you'll need to fill out. One, hey, is there a relationship between the magnitude of the acceleration and the mass? Hopefully you'll notice what's happening there. Compare the value for the acceleration from delta V over delta T and for that F net over mass. Notice what happens there. Make an interaction diagram and quantitative force diagram for any of the situations you were just looking at. It could be this one here if you'd like to. Okay. And then last one, this bonus. Hey, one of the items here has a question mark. We don't know what the mass is, but write up a way that you could figure that out and what the appropriate, what the mass you figured out from your experiment. I'll show you that It's that little box here. We don't know what its mass is. All right, but figure out a way of determining that. That's be a little bit of a bonus. All right, hey, so good luck with this.